A four-stroke, also four-cycle, engine is an internal combustion (IC) engine in which the piston completes four separate strokes while turning the crankshaft. A stroke refers to the full travel of the piston along the cylinder, in either direction. The four separate strokes are termed intake, also known as induction or suction. This stroke of the piston begins at top dead center, TDC, and ends at bottom dead center, BDC. In this stroke the intake valve must be in the open position while the piston pulls an air-fuel mixture into the cylinder by producing vacuum pressure into the cylinder through its downward motion. The piston is moving down as air is being sucked in by the downward motion against the piston. Compression. This stroke begins at BDC, or just at the end of the suction stroke, and ends at TDC. In this stroke the piston compresses the air-fuel mixture in preparation for ignition during the power stroke, below. Both the intake and exhaust valves are closed during this stage. Combustion, also known as power or ignition. This is the start of the second revolution of the four-stroke cycle. At this point the crankshaft has completed a full 360-degree revolution. While the piston is at TDC, the end of the compression stroke, the compressed air-fuel mixture is ignited by a spark plug, in a gasoline engine, or by heat generated by high compression diesel engines, forcefully returning the piston to BDC. This stroke produces mechanical work from the engine to turn the crankshaft. Exhaust, also known as outlet. During the exhaust stroke, the piston, once again, returns from BDC to TDC while the exhaust valve is open. This action expels the spent air-fuel mixture through the exhaust valve. Otto Cycle was a traveling salesman for a grocery concern. In his travels, he encountered the internal combustion engine built in Paris by Belgian expatriate Jean-Joseph Etienne Lenoir. In 1860, Lenoir successfully created a double-acting engine that ran on illuminating gas at 4% efficiency. The 18-liter Lenoir engine produced only 2 horsepower. The Lenoir engine ran on illuminating gas made from coal, which had been developed in Paris by Philippe Lebon. 1. In testing a replica of the Lenoir engine in 1861, Otto became aware of the effects of compression on the fuel charge. In 1862, Otto attempted to produce an engine to improve on the poor efficiency and reliability of the Lenoir engine. He tried to create an engine that would compress the fuel mixture prior to ignition, but failed as that engine would run no more than a few minutes prior to its destruction. Many other engineers were trying to solve the problem, with no success. 1. In 1864, Otto and Eugen Langen founded the first internal combustion engine production company, Na Otto & C., Na Otto & Company. Otto & C. succeeded in creating a successful atmospheric engine that same year. 1. The factory ran out of space and was moved to the town of Deutz, Germany in 1869, where the company was renamed to Deutsche Gasmotorenfabrik AG, the Deutsche Gas Engine Manufacturing Company. 1. In 1872, Gottlieb Daimler was technical director and Wilhelm Maybach was the head of engine design. Daimler was a gunsmith who had worked on the Lenoir engine. By 1876, Otto and Langen succeeded in creating the first internal combustion engine that compressed the fuel mixture prior to combustion for far higher efficiency than any engine created to this time. Daimler and Maybach left their employ at Otto & C and developed the first high-speed Otto engine in 1883. In 1885, they produced the first automobile to be equipped with an Otto engine. The Daimler E-Twinken used a hot tube ignition system and the fuel known as Legroin to become the world's first vehicle powered by an internal combustion engine. It used a four-stroke engine based on Otto's design. The following year, Carl Benz produced a four-stroke engined automobile that is regarded as the first car. 2. In 1884, Otto's company, then known as Gasmotorenfabrik Deutz, GFD, developed electric ignition in the carburetor. In 1890, Daimler and Maybach formed a company known as Daimler Motor and Gesellschaft. Today, that company is Daimler-Benz. Atkinson cycle. The Atkinson cycle engine is a type of single-stroke internal combustion engine invented by James Atkinson in 1882. The Atkinson cycle is designed to provide efficiency at the expense of power density, and is used in some modern hybrid electric applications. The original Atkinson cycle piston engine allowed the intake, compression, power, and exhaust strokes of the four-stroke cycle to occur in a single turn of the crankshaft and was designed to avoid infringing certain patents covering Otto cycle engines. 3. Due to the unique crankshaft design of the Atkinson, its expansion ratio can differ from its compression ratio and, with a power stroke longer than its compression stroke, the engine can achieve greater thermal efficiency than a traditional piston engine. While Atkinson's original design is no more than a historical curiosity, many modern engines use unconventional valve timing to produce the effect of a shorter compression stroke, longer power stroke, thus realizing the fuel economy improvements the Atkinson cycle can provide. Diesel cycle. The diesel engine is a technical refinement of the 1876 Otto cycle engine. Where Otto had realized in 1861 that the efficiency of the engine could be increased by first compressing the fuel mixture prior to its ignition, Rudolf Diesel wanted to develop a more efficient type of engine that could run on much heavier fuel. The Lenoir, Otto atmospheric, and Otto compression engines, both 1861 and 1876, were designed to run on illuminating gas, coal gas. With the same motivation as Otto, Diesel wanted to create an engine that would give small industrial companies their own power source to enable them to compete against larger companies, and like Otto, to get away from the requirement to be tied to a municipal fuel supply. Like Otto, it took more than a decade to produce the high-compression engine that could self-ignite fuel sprayed into the cylinder. Diesel used an air spray combined with fuel in his first engine. During initial development, one of the engines burst, nearly killing Diesel. He persisted, and finally created a successful engine in 1893. The high-compression engine, which ignites its fuel by the heat of compression, is now called the diesel engine, whether a four-stroke or two-stroke design. The four-stroke diesel engine has been used in the majority of heavy-duty applications for many decades. It uses a heavy fuel containing more energy and requiring less refinement to produce. The most efficient Otto cycle engines run near 30% thermal efficiency,